All right, this is a summary from today's class. So the first example we're going to go over is 2 2/3 times 2 2/3. So my first step is that I want to make these mixed numbers into improper fractions. So I'm going to multiply first, and then I'm going to add in the numerator. So 3 times 2 is 6, plus 2 is 8. So we have 8 over 3 times 8 over 3. Now I cannot cross cancel anything here. Both 8 and 3 do not have a number that can divide into both of them except for 1. So I'm going to keep it exactly the same and multiply straight across. So 8 times 8 is going to give us 64, and 3 times 3 gives us 9. Now if I want to change this back into a mixed number, I'm going to divide 9 into 64. We know 9 cannot divide into 6, but 9 can divide into 64 7 times. 9 times 7 is 63, and we are left with 1. So our mixed number would be 7 and 1/9. Either one of those answers would be correct. All right, for my next example, I have 3 3/10 divided by 1 4/7. I'm going to change these to improper fractions, so 10 times 3 is 30, plus 3 is 33. 1 times 7 is 7, plus 4 is 11. Now when I'm dividing fractions, because not everything is always going to divide in evenly, for example, 33 divided by 11 would give us 3, but 10 divided by 7 is going to give us a decimal. We're going to get 1 point something. And we don't want those decimals in our answer. So instead of dividing to get a decimal, we are going to keep our first fraction, we're going to change our division to multiplication, and we're going to take the reciprocal or flip the second fraction. Now there's two ways I can do this. I can multiply straight across and say 33 times 7 is 231, and 10 times 11 is 110, and then I would have to simplify this, which right off the top of my head, I don't know what goes into both 231 and 110. So an easier way to do this, so we don't have to simplify such a big number, is to cross cancel. So if I look at 10 and 7, nothing can divide into both of those. But if I look at 33 and 11, both of those can be divided by 11. So 33 divided by 11 now becomes 3. So I would have 3/10 times 7 over, and 11 divided by 11 is going to give us 1, which gives us a much simpler problem to solve. And now I just multiply straight across. So 3 times 7 is 21, and 10 times 1 is 10. And now I can change this back into a mixed number. So 10 goes into 21 2 times. I would have 1 left over, and 10 remains my denominator. All right, our next example, 1 2/9 times 1 4/5. So 9 times 1 is 9, plus 2 is 11. 5 times 1 is 5, plus 4 is 9. Right, and let's try to cross cancel so I don't get big numbers. So if I look at 9 and 9, those can both be divided by 1, 3, or 9. And I'm going to pick the biggest one, so I'm going to divide it by 9. 11 and 5 cannot be divided by anything except 1. So we're going to keep those the same. So I'm going to get 11 over 1, because 9 divided by 9 is 1, times 1 over 5. And now I'm just going to multiply straight across. So 11 times 1 is 11, 1 times 5 is 5, and I know that 5 goes into 11 2 times. I would have 1 left over, 5 stays my denominator. All right, and lastly, 5 divided by 3 1/3. So 5 is a whole number, so I want to set 5 over 1 to make it into a fraction. So now I have 5 over 1 divided by, and 3 times 3 is 9, plus 1 is 10. Right, again, I'm going to keep that first fraction. I'm going to change the division to multiplication, and then I'm going to flip the second fraction. Right, and let's try to cross cancel. So if I look at 5 and 10, both of those can be divided by 5. So 5 divided by 5 is going to give us 1. So I have 1 over 1 times 3 over 2, because 10 divided by 5 gives us 2. And I'm going to multiply straight across. 1 times 3 is 3, 1 times 2 is 2. 3 divided by 2 is going to give us 1 and 1/2. Again, remember that you can multiply straight across too. So if I had done 5 over 1 times 3 over 10, I would have gotten 15 over 10, which gives us 1 and 5/10, which also simplifies to 1 1/2. So if you cross cancel, it just saves you time from simplifying. And sometimes it's easier to simplify the smaller numbers than it is to simplify bigger numbers.